A firm has a marginal cost function of 0.6q plus 2, where q is the number of units of output. Currently, it's producing 80 units of output. We want to work out the extra cost involved in producing an extra 20 units of output, so increasing to 100 units. Before we go on to the actual integration problem, let's review some of the economics behind this. Recall that marginal cost is the cost of one additional unit of output. So marginal cost is equal to 0.6q plus 2. So the marginal cost varies with the quantity, and that's equal to the first root of the total cost function, dTc dq. We want to find the change in total costs, delta total costs, when production goes from 80 to 100 units. That'll be total costs for 100 units minus the total cost for 80 units. Looking at that in terms of the marginal cost function, Q marginal cost of our marginal cost function there. We want to find the area under the curve. That'll be the change in total cost. That's also the change in total variable cost. Remember, total cost is total variable cost plus total fixed cost. It's the change in total variable costs because the total fixed costs are fixed. They don't change. Let's go on to the integration. Given our marginal cost function, that implies the change in total costs will be, well, the integral from 80 to 100 of our marginal costs, 0.6q plus 2 dq. Integrating that, we'll have 0.6 as the coefficient. That'll be q. A is 1, so the new coefficient will be 1 plus 1. We'll divide by a plus 1, 1 plus 1. Plus, well, 2 is a constant, so applying our constant rule, we'll have 2 times q. And we're evaluating that from 80 to 100. Simplifying that, we 0.3 times q squared plus 2q. We evaluate that function at 100 and then subtract the function evaluated at 80. So we'll have 0.3 times 100 squared plus 2 times 100, a big bracket around that, minus 0.3 times 80 squared plus 2 times 80, another bracket around that. Doing those calculations, we'll find that's 3,200 minus 2,080, and that's equal to 1,120. Put our conclusions then. Total costs increased by 1,120.